Hi, my name is Vicky Ramsey and I've been studying physics since 2006. In episode 1 of my ENA video series, I talked about general relativity in relation to the calibration of atomic clocks, where, because clocks tick slower closer to the gravitational mass, it is thought that clocks will tick slower on the bigger mass. I made a case via the principle of mass-energy equivalence and the equation E = mc squared that Einstein's general relativity denotes that an atomic clock should require less energy in order to tick faster, when it is my observation that an atomic clock requires more energy in order to tick faster. I backed up this claim by providing data from a GPS engineering paper where, amongst other aspects, it was shown that a clock ticking slower has a lower frequency than a clock that is ticking faster. And it is a well-known fact in established physics that frequency and energy are proportional. I talked in detail about how, if I am right about an atomic clock requiring more energy in order to tick faster, general relativity would have to be amended to state that clocks tick faster higher up within a gravity potential and clocks tick faster in the greater gravitational field. In episode 2, I talked about how this amendment to general relativity would not require any changes to the general relativity equations, and how the addition of only 6 operations of modification in the form of axioms provides an alternative to the current interpretation of the general relativity mathematics. In episode 3, I talked about how interpreting the general relativity equations under the remit of these 6 axioms results that the universe cannot be expanding and must instead be contracting. I also talked about how, via these modifications, the observation of the redshift distance correlation can be reinterpreted. And I hinted as to how this reinterpretation can provide a cause and effect explanation for the observed 5 sigma Hubble tension. I want to talk here about this 5 sigma Hubble tension in relation to the redshift distance correlation. So, to give a bit of background, in the 1920s, Hubble's observation of the redshift distance correlation became the catalyst for the Big Bang theory. The further away a light source, such as a star, is from our solar system, the greater the observed redshift. Therefore, by applying the effect of a Doppler shift of light, the further a star is, the faster it is moving away from the observer, where, as a point of logical progression, it was determined that the universe must be expanding. And, in order to determine the age of the universe, it became pertinent to inquire as to the rate or speed of the universe's expansion. Okay, so pre-1998, cosmologists had been expecting to find that the universe's expansion would be slowing down due to the force of gravity, and that eventually the expansion would grind to a halt and the universe would start to collapse upon itself. But this turned out not to be the case. Researchers were astounded to find that the universe's expansion rate is actually accelerating, resulting in cosmologists Brian Schmidt, Adam Rees and Saul Perlmutter being awarded the 2011 Nobel Prize in Physics. However, it turns out that although the researchers are certain that the rate of the universe's expansion is accelerating, the actual speed of the expansion itself is not so clear. There are discrepancies between the different methods of measuring the expansion rate, where each method results a different speed. Based on the fundamental physics that scientists believe to have driven the evolution of the universe, the Hubble constant should be around 68 kilometers per second. But, according to the Planck satellite measurements involving the cosmic microwave background, the expansion rate is 67.4 kilometers per second. According to Wendy Freeman and Co.'s measurements involving red giants, the expansion rate is 69.8 kilometers per second. According to preliminary results from Daniel Holtz and Co.'s measurements involving colliding neutron stars with respect to the resulting gravitational waves, the expansion rate is 70 kilometers per second. According to Nandita and Co.'s measurements involving supernova with respect to surface brightness fluctuations, the expansion rate is 70.5 kilometers per second. And according to Adam Rees and Co.'s measurements involving Cepheid variables, the expansion rate is 74.03 kilometers per second, leaving cosmologists puzzled because, as per the Big Bang theory, the universe should be expanding at the same speed everywhere, a phenomenon known as the Hubble flow. The fact of these different methods of measurement having failed to measure the same speed is currently known as the Hubble tension. What I wish to discuss here is this Hubble tension in relation to my proposed reinterpretation of the redshift distance correlation, and how this new interpretation of the redshift distance correlation can give cause and effect explanation for the Hubble tension measurements. Okay, so it isn't actually accurate to attribute the light sources of galaxies themselves as having a Hubble flow velocity. This being because it is the space between these cosmic structures that is expanding, causing the distances between these large-scale structures to increase. But to be clear, it is the rate at which the distances between these structures are increasing that determines the speed of the Hubble flow describing the universe's expansion. Also, the situation is somewhat complicated by the fact that everything in the universe is in some type of motion relative to everything else. The Earth is in motion orbiting the Sun, and the Sun is in motion orbiting the black hole at the centre of the Milky Way. And where the Milky Way is a galaxy that is closely neighboured by satellite dwarf galaxies, forming part of what is known as the local group with the relatively nearby Andromeda and Triangulum, inclusive of their satellite dwarf galaxies, the Milky Way's local group is a small galaxy cluster that is a relative neighbour to the much larger Virgo galaxy cluster, which, in addition with many other galaxy clusters, forms part of the Virgo supercluster, which, in addition with 3 other superclusters, forms part of a galactic supercluster named Laniakea. The Milky Way, being a galaxy that is part of this galactic supercluster, is itself caught up in a type of motion known as a galactic flow, that is dragging the entirety of this galactic supercluster, known as Laniakea, at a speed of 600 kilometers per second towards a phenomenon that has been dubbed as the Great Attractor. I will be discussing these galactic flow phenomena in far greater detail in episode 5, but for the purposes of this discussion, the speed of the galactic flow towards the Great Attractor is known as a peculiar velocity. Not to be confused with the Hubble flow, which is referring to the distances of space between galactic structures increasing with a speed that is known as the Hubble constant, where the Hubble constant is the physics terminology given for the speed of the universe's expansion. However, to be very clear, galaxies that are adjacent to each other, such as the Milky Way, Andromeda, and Triangulum, do form into galaxy clusters. And galaxies within galaxy clusters are not increasing in distance from each other with the universe's expansion. In fact, galaxies that have formed into galaxy clusters do the exact opposite and are moving closer together under the influence of gravity, where they will eventually end up merging with one another. As with the Doppler shift of light, when a galaxy is moving further away from our Milky Way, we observe light sources to be redshifted. And when galaxies move closer to our Milky Way, such as Andromeda and some of the galaxies on the far side of the Virgo cluster, we observe those light sources to be blue shifted. It is this observation of blue shifted light that has caused us to understand that galaxy clusters are gravitationally bound, and that galaxies within galaxy clusters are converging upon each other under the influence of gravity. Okay, so now to the nitty-gritty. In episode 3, as part of my discussion regarding a cyclic contracting bounce universe as an alternative cosmological model, I hinted, via my proposed addition of the axiom, the speed of light cannot exceed the local rate of time, that only about 8 or so % of the observed cosmological redshift is due to Doppler shift. And the rest is due to these time dilation effects that I have proposed as being inherent to space itself. To recap, I have suggested that the universe has 2 time dimensions. The regular time dimension that we observe as the timing of clocks for mass, and an additional hidden time dimension for where m equals 0, i.e. open space, that can only be indirectly observed due to its effects, where these 2 time dimensions occur separately from each other but concurrently to each other. And, as opposed to the rates of time for mass becoming faster with distance from the gravitational mass, the rates of time for space do the opposite and get slower with distance from the gravitational mass, where, as the shifting of light is regarding massless photons travelling through open space, this proposed hidden time dimension becomes the mechanism by which an alternative interpretation of the redshift distance correlation can be obtained. Okay, so I said that I am proposing that only around 8% of the observed redshift is due to Doppler shift. To be more precise, the percentage of the redshift due to Doppler shift under the regime that I am suggesting would be dependent on the dynamics of the location in space that the light source is situated. For instance, red giants are located in much less dynamical areas of space than Cepheid variables. By using the cosmic microwave background measurements as a baseline, if one then subtracts the cosmic microwave background related speed of 67.4 kilometers per second from the speed measured by different methods, for instance, Cepheid variables at 74.03 kilometers per second minus the cosmic microwave background speed of 67.4 kilometers per second equals 6.63 kilometers per second, then 6.63 kilometers per second is now the Doppler shift speed for the Cepheid variables. Clearly, subtracting the cosmic microwave background speeds from the progressively lesser speeds measured via the other types of light sources I listed previously will then result in progressively lower Doppler shift speeds for these differing types of light sources. So, these alternative Doppler shift speeds of 6.63 kilometers per second and less are now describing the speed at which these different light sources are converging upon each other within their galaxy cluster groups, where this phenomenon of convergence then causes the distances between galaxy cluster groups to be increased, where we can observe that more dynamical clusters are inherent with Cepheid variables, and less dynamical clusters are inherent with red giants, and so on. More dynamical locations can then be synonymous with the presence of more energy, and the axiom plus energy equals shorter seconds can then result the rates of time in space in more dynamical locations as being faster than the rates of time in less dynamical locations. So, galaxies converging upon each other, when their velocities are held relative to shorter seconds, will move at greater speeds. And conversely, when velocity is held relative to longer seconds, galaxies will move at lesser speeds. These being part of the observable effects for a hidden time dimension in space, giving us a partial description of cause and effect mechanics for how gravity does what gravity does, and fully described cause and effect mechanics for this Hubble tension phenomenon, where differing methods of measuring the redshift distance correlation yield different speeds for the Hubble constant. The remainder of the observed magnitude of the redshift is then not Doppler shift related, and is instead caused by the rates of time for space in the voids between galaxy clusters becoming slower, as the distances between these clusters are increased due to the galaxies of these clusters becoming ever closer to each other. where the mechanics of this hidden time dimension require one to envisage that, rather than light being stretched by the length of the distance the light is travelling through in space being increased, that the light is stretched by an increase in the length of the seconds that are inherent across the distance of space the light is travelling through. And it is in this fashion that the Hubble tension could be regarded as evidence with which to support a contracting universe hypothesis. I will be dedicating episode 5 to a detailed description regarding my model for a cyclic contracting bounce universe. But meanwhile, I have left links to all of the aspects that I have discussed today in the video notes. Thanks for watching.